So, as discussed yesterday, uh, we're going to use a schema called SAP underscore HANA underscore demo, and we have understood the tables what was available in there. So yesterday we have seen all the tables. So we understood about this data, right? About business partner, products, employees, about the notes, and then constants, what we had, and the text we had, right? And then the sales order data and the purchase order data, right? With header and item. Right? So now, we'll get into creating the modeling views. So the modeling content is created in this content folder. We basically organize this modeling content in form by using packages. So what we do is now let me just create a package and then we create the views here. And the content folder, just right click and say new package. Cubics modeling. Yeah. So this is the name of the package. I can give description. There is something called delivery unit. So now let's not worry on this. But for now, just understand delivery unit as a container to transport the modeling content objects from one environment to another environment. Let's say I'm creating this package, and this package under this package I'm going to create a lot of views. Let's say we are doing this in the development environment. Now you want to transport them to quality and then to production. So what we can do is, so when you want to transport this package and the views, it must be assigned to a delivery unit. So delivery unit will be a container which will be carrying this package and the models. Then we can leverage this delivery unit and then transport it to quality and then to production. So when I want to transport, then I'll go with this delivery unit bus. Now I don't need this. Then this language and the person who's creating this is then okay. So this is how I just create a package. Yeah, package is just like a folder where you basically organize your HANA modeling content bus. Okay? So I have this package. Now under this again, if I want to create sub packages within this, I can do this. So I can say right click again and say new again package. Okay? You can just create further packages under this also. So then it comes with a hierarchy maintained with this dot cubex modeling dot. Say I would say models. Okay, and then that's the description. So I can have sub packages created like this. So you can go up creating n number of levels of sub packages, not a problem. Okay. Package purpose is not to transport. Okay. Package purpose is to organize your models, and the purpose of delivery unit is to transport is for transporting this. Okay. So the purpose of package is to organize your models, and then when you want to transport this package along with the models, we assign them to a delivery unit and then do so. Okay. Hmm. So we're getting into calculation views, right? One second. So we're getting into calculation views. Okay. So with under this package, we can basically create your calculation views first. Okay. Now right click on this package and then say new. You have option of creating either attribute view, analytical view, calculation view, privileges, all this stuff we'll get in. But now our point of focus is calculation views. Now say calculation view. Now when you say calculation view, here basically it will ask you for the name of the view, what you would like to create. So We would have some naming convention depending on the project, but for me, I'm just going with Z CV. Z indicates it's a custom object. CV indicating it's a calculation view, and then I'm just saying something like 001, some number. Okay. Now, next property is about specifying the name of the package under which this view is getting created. So this view is getting created under Cubex modeling dot models. Okay, good. And the type of view what we're creating is calculation view. We also have option of copy from. Say if you want to create this calculation view similar to another calculation view, then just tweak it a little bit. Then I can use copy from this. So, so I can just select other views which is available. If I just select this, it's going to create a calculation which is copy of this. Okay, I don't want that now. Then okay, we've decided about we want to create the calculation view. Fine, but within this calculation view, what type of view do you? Because we have two types of calculation views again within this. We can create subtypes. One is standard or times. So we can create calculation view subtype could be standard or time. We'll come to this time later, but I'm saying normal standard. And then we can have two types. See, this is subtype. Okay, subtype is standard or time, but within this calculation we can have two types. One is graphical view and SQL script. So you can create a calculation view by using graphical mode or by writing your SQL script also. Okay. So you want to create calculation with graphical node or scripting. So I want to go with graphical node. And then there's a data category bus, very, very important property. Cube, dimension, and then there is something called blank. Okay. When we use this data category as a dimension, it means that you're going to create a calculation view which does not have any measures. Measure means in BW we were referring as key figures. In BW, whatever we are referring it as key figures, which can be aggregated, okay, which can be quantified. In BO, whatever we have measures, in HANA we call them same as measures. But in BW, whatever we had something like key figures, which can be quantified like revenue, quantity, price, net sales, okay. All this will be referred as measures here. So, and in BW, whatever we had as dimension, sorry, in BO dimension, we'll have it as dimension here. In BW, whatever we had it as characteristic, here we refer it as attribute bus. Here we refer it as attribute bus. Yeah, label is description. Sorry. Okay. Ah. So when you say data category as dimension, your view will not contain any measures. So whenever you want to define a calculation view which does not contain any measures in it and will not be available for reporting, we go with data category as dimensions. So whenever you create a calculation view with data category as dimension, it cannot hold any measures. So when there is no measures, no aggregation, nothing, and it is not available for reporting directly. So you cannot do reporting on this type of views. Okay, and I will see that. So it says by default the node is projection node. Okay, and when you say blank, so for these type of views where the data category is blank, okay, it can have measures. So these type of views can hold measures in it, like key figures, but still not available for reporting. So the default node will be still as projection only. Okay. Now when I say cube, when you say cube, now it will start allowing you to have measures in it, and it is available for reporting also. Sorry. So when you say data category as cube, we can have measures in it in defining the views, and we can do reporting on top of it also. And then the default node will be aggregation. We'll see what is aggregation, what is projection. But when the data category is cube, you have an option of specifying with star join bus. So when you say, so this with star join option is available only when the data category is cube. When you say set as cube, you have this option with star join. So when you select star join, again it is enabled for reporting. You can have measures, but then the default node would be star join. We'll see that option. Okay. Now let's say now I'm creating with dimension. Say finish. Now you see this modeling canvas, right? So this is the environment where you basically go about creating a calculation. See, so this is what you call it as a node. Each one is as node, and this is the default node which is set as projection bus. So by default, you see this node as projection node because the data category is dimension. Okay. Let me not do anything, and I'll just okay. I'll just close it out. Just create one more calculation view. ZCV underscore 002 calculation view, again standard graphical. Now I'm going with blank. Finish. Again, even for blank, even when the data category is blank, you still see the default node as projection, but not allowed for reporting this. Let me create calculation view again. 3 standard again, but now this time data category is cube. Okay, fine. Now you see the default node as what? Aggregation. Now when it's aggregation, this is for performing sum of aggregation function on the measures. Now it enabled it, we can do reporting on this view, which is because data category is cube. Okay. Now let me create a calculation view. Graphical. I say cube, but with star join. Okay. Now again, it will allow you to have measures, but the default node would be star joins. That's the difference between all those options there. Okay. Good. All these were graphical. Create graph again ZCV005. Okay. Let me have it as cube. Let me have it as cube is fine, and then say okay. Now this is graphical, right? Now what happens when you're building graphical calculation view? Ultimately, you're building this view when you want to model your data. Means you want to pick data from multiple tables, or you want to project only certain columns of a table, or you want to apply some filtering on those data. All this can be done. Yeah. You want to increase the font size. I'm not able to do this now, but hmm, but if I increase the font, one sec. Now it's better. Okay. See now when you're building this calculation view with graphical, you have so ultimately you want to model your data. So what they do is you have been given different operations what can be performed. Like say you have join operation, union, projection, aggregation, and then rank. So I can, depending on the requirement, in the modeling canvas, you can just basically drag your operations like join. So or you can drag your union, or you can have use projection node, or you can use aggregation node, or you can use rank node. So you can basically use either of these nodes n number of times, not only once. You can use these nodes n number of times and start building your logic what you would like to apply as part of the modeling. Okay. So each node, like say join, aggregation, projection, union, or rank, will have a different flexibility or functionality what it can be, what you can perform on this. Okay, good. Now concentrate. First, projection bus. Two major requirements what you can achieve with the projection node. Say I have a requirement like this. What kind of join it is left? No, no, don't worry on that. Don't go to that level now. Just say I'll come to the each node now. Projection. Why do we use projection? Let's say I have a table with 10 columns, but I would like to project only five columns of the table to the business, okay, or to the business reporting or business users. Okay. In that case, I can use projection. So what I'll do, I'll project a table which has got 10 columns, but I'll just project only the five columns of it. That where I can use projection. For example, say projection. I take the projection node. I can add some table for the projection. Which table? Let's say I want to add sap.hana.demo. Sap.hana. Yeah. What is my table name? Content dot epm. A lot of tables. Or instead of so much, what you can do, you can search for those tables, or I can just drag and drop. Also. Go to content. Let's say I would like to use this table business partner, or you can drag and drop on the table links. So I can get the projection of this table. So this table has got lot of columns, but I just want to have only certain columns. Let's say now here you can see the selected columns. See now the columns, output columns are nothing. There's zero. So I can just select what I just want partner ID. Select this. I want partner role. I want email address. I want phone number. Then I want the company name. I want the legal form. I want the currency. Like this, you can just project only certain columns. So now look at this. In the output, it starts adding up the columns what you're projecting out. So like this, I can use this projection node when you want to project only certain columns of a data source. See, here I'm using table. Data source means what is for this projection? What is the source? The table is a source. Okay, we call that as data source. We call that terminology as data source or source. Okay. So when you want to project only certain columns of a table, okay, we use the projection node. That is one first point. Okay. Next is apart from this, we also use the projection node when you want to apply the filtering. Say, for example, I would like to say, if you remember, there was something called partner role, which was indicating 0102. Say, from this table, I would like to read only those records where my partner role is only 01, okay, where my partner role is, let's say, 02. So it's similar like select so and so columns from this table where my partner role is 01 or 02. So when you want to apply some filters, okay, so I can just select this field partner role, right click and say what apply filter. Operator whether it could be equal to, not equal to, between, list of values, contents, but anything, okay, equal to which value. Now let's say I want to say 2. Okay. So now with this projection, what all we have done, instead of saying select star, I said select partner ID, partner role, email address, phone number, company name, legal form, currency from this table where partner ID is 2 bus. So second point with the projection, we can also apply filtering of data with projection bus. So you would use projection node when you want to only project certain columns of a table, certain columns of the source object. what is selected into that node. And then when you want to apply filtering on this particular source, when you want to apply the filters, okay, that's where we use projection node. Okay, 2 points. Apart from this, apart from projecting the columns and applying filtering, we can also have projects. We can also use projection node when you want to define calculated columns. Here, look at this. See, these are the columns which are being selected first, right? These are the columns which are being projected. Apart from these columns, let's say, apart from the columns, what is there in the source, you have to implement a logic to derive a new column. You can do that by using calculated columns. Like, look at this, select this calculate column, right click and say new, and you can basically start defining. You can start defining the calculation what you want. You can leverage the columns what is already selected and operators, functions, and then build your logic and define a new column. Okay, so this is called as deriving a new column also. Okay, but to be focused here, when you're building a new column in this whenever building a calculate column in the projection node, we are not determining whether this column is a measure or whether this column is a attribute or whether it is characteristic or a key figure bus. You just define the calculation what you can do, but you're not really determining whether it is a measure or whether it's an attribute as of now. Okay, so all these flexibilities can be done with projection bus. You all understand when now. Once you understand this, as whenever you get some requirement, you should be in a position to understand which node to be or which operator should I leverage in this particular case. So I can use projection when you want to project only certain columns of the source object and apply filtering, and we can also derive new calculate columns by using projection. Okay, boss? Fine, good. Next, we have aggregation. We have next operator as aggregation. And one, okay, I'll come to that later. Okay, next is aggregation. The purpose of this aggregation is, if you remember in the select statement, you can write sum of, count of, average of, min of, max of. When you want, so whenever you deal with measures, you would like to apply some aggregation functions on top of it, like say sum of revenue. Say, now look at this requirement. What I have now. I have this. I have this table. I know if you all remember, I have a table called sales order item, which gives me. Now let me just select this aggregation. So I've just selected this source object, which is a table sales order item. Okay, so which has got all those columns. Now each record in this table is one sales order specific to an item bus, right? Good. Now what I want is from this table, I want to see the aggregation of gross amount with respect to product bus. Because there might be multiple records of the same product, right? I would like to aggregate that amount. I would like to aggregate that amount. I want to see sum of. I would like to see select product ID, sum of gross amount from this table, group by product bus. So I would like to aggregate the gross amount with respect to product ID bus. So then how do I do this? Now I'll say I want to see. I'll say add as normal output. I want product ID. But whereas gross amount, I would like to add this as an aggregated column. So you look at this 1 and 2 indicate it's a measure, and AB indicates it's a character bus or an attribute. Okay. Only for measures you can perform the aggregation. So I say gross amount, right click, add as aggregated column. Now you see this gross amount. You see, look at the symbol here. It says some aggregated column here. Okay. Now what aggregation it has to be done? You can specify it here. Now select this. Here you can see engine aggregation is by default sum, but you can change it to min, max, or count. So if you select sum, then it will be what? Select product ID, sum of gross amount from this source, group by product ID bus. Okay. But if I select same way as say count, it will say what? Then select product ID, count of amount from this source group by product ID, right? Now I still want it as sum. Apart from product, let's say I also want to see currency also. Now this is again AB, it's again attribute. Let's say add as output. Then it will be what? Select product ID, comma currency, comma sum of gross amount from the source object group by product ID, comma product currency. So depending on how many columns you select, it all those attributes, whether how many attributes you select in this aggregation node, they all will play in your group by class. Got this point about aggregation? Any doubts, boss, on this aggregation node? Still, apart from this, apart from performing the aggregation, if you see, I'm able to select some columns like projection. So what are the functionality of selecting certain columns of the source, like choosing what columns you want? I'm able to do that in projection as well as in aggregation. But in aggregation, I have to specify at least one aggregation here, and I cannot apply filtering here. For example, if I want to apply filter on currency, I can, if I say, sorry, I can apply filtering here also, apply filter, and same what you're able to apply filter, I can applying filter here also. Same like projection. Same like projection, I can choose the columns, apply filtering, but only thing is when I'm choosing at least there should be one measure selected, specified with aggregation function here. That's the only difference here. In project, whatever you are able to do with projection, I can do that with aggregation, but only difference is you must have an aggregation function specified for at least one measure here. Okay. Then I can also define my calculated columns here. Then I can just specify what is the name, and then you can use columns, and then you can use operators and functions, and you can define a new calculation or new calculate column. That is the flexibility of using aggregation nodes. So whenever you want to aggregate the measures, say perform an aggregation function on the measures by performing some group by on any of the attributes, then we go with aggregation node. So similar to projection, I can enable the function of choosing certain columns and also applying filtering on this. Clear on this? Okay. Okay, good. Now, what is language column engine? Language. No, don't worry. Now I'll come to that language column always. Next we have something called join. Okay. Basically, join, we all know it's pretty common. We use this join node when you want to join multiple source objects. Say, for example, I have what are the information I want. It's available in two source objects, whether it is, say, two tables. For now, you understand as tables or source is all one and same. So I have, let's say, business partner table. I have address table. So business partner table gives me the name and all the stuff. And for more details on the address, I'll have to get into the address table. So when I want to have a view of both this address and the partner details, I will have to join both these tables. I'll have to join both these tables out. So in that case, I would like to establish an association between those two tables. That's where we use the join operator. Okay. So but using a join node, we can only join two tables or two source objects. Let's say now I want to do this. Say for example, I want to take source object one as data source, business partner. Then I would like to take the address. See here, I am basically, you're seeing the properties of the join node, where I've just selected two tables. Okay. One is I've got business partner table and one is address table. I've got business partner table and address table, right? So now I need some columns from business partner table. I need some columns from address. So when I do this, I need to establish an association relationship with each of these tables or join those tables first. So if you look at this, in the business partner table, I have address ID. By using this address ID, I can establish a join to this table to get the more information on the address, right? So how do I establish a join? I can just drag and drop. on these columns like this, and then you see this join is been selected. Here you can see the properties of the join. What join is it? What is this join type here? Because when you join tables, you'll have different types of joins. We'll see that point later. But now see what is this here? By default, it is inner join, but you can go with left outer join, right outer join, text join, full outer, and reference. We'll come to these joins later. See inner join, right? Or instead of doing this way, okay, instead of doing this way, what I can do, you can just right click and say what? Create join. Then tell me what should be your left table, say business partner, and the right table is address. Then you can basically sorry. Then you can basically drag and drop here address ID to address column. Yeah, here you can specify what type of join you want, inner join or what is it. We'll see all this dynamic joins, all this stuff, and what is the cardinality, what is the relationship between these tables. So there could be one partner with the same address, right? Or one address ID could be used in multiple partners. Means one address ID could be referred in multiple partners. So I would say one to many means one customer can be referring, one partner can be referring to or multiple address or it's other way. So it will be one partner will not have multiple. So it is many customers will be referring to one particular address. Possible like this you can content is not important, but you specify the how the data has been related here. Like this, we'll get into joint types later. We'll have temporal joints, geospatial joints, and then referential temporal joints, dynamic joints. All this we'll get it later. But now, just say okay, and that's how you can basically establish a join between the tables. Okay, and then start selecting what you want, and then projection of the columns what you want from each of them. I want partner ID, role, and then say company name, and then legal form, currency from this. From here, I want city, postal code, street, and then country, and then region. This is how you can basically go on with the join operation. So apart from choosing the joining the tables, I can also define my own calculate column also. Okay, but we cannot apply filtering here. Filtering is not possible. Filtering can be done only in the projection node or aggregation node. So like this, you can basically establish a join between multiple tables. But one join operator can only join two tables or two source objects. So, but if I have the requirement of joining three tables, what should I do? So first you joined two tables with join node, right? You take one more join node, okay? Connect the result of this join node to this. That will be acting as one source, and take this. Let's say I want to go with constants. Now take this again another as another table. Now I would like to join something like say partner role to this fixed value. Like this, you can go with joining to n number of levels. But in one join node, we can only join two source objects, whether it is table or it should be below node. Okay, that's about join. Then I have then we have another operator called union bus. We'll have another operator called but filtering cannot be done in join nodes. Only in projection and aggregation we can apply filters. Next is about union bus. Now, what is the purpose of union here? When you look at union, basically when you want to combine data set, let's say you have two data sets or three data sets, you would like to union all those data sets and project as one data set, then we can use union. Say for example, I have sales data of Europe and I've got sales data of North America and then I've got sales data of Asia Pacific. And I would like to union all the sales data and then project it as a global sales. Then I can use my union operator. So by using union, I can basically combine the multiple data. It's like union set. Say if I say union of A plus B plus C, it will take data of A, it will take all the data of B, it will take all the data of C. Then I can use my union operator. Okay, we'll see that in detail. Then I have rank node. rank node, when you want to do some sorting and specify the ranking was. Generally, when how do you do ranking? You will have some certain measure through which you perform your ranking. Then you specify the descending order or ascending order, and then pick top five or top six or whatever you want. Okay, so that's where we do the rank operators. Okay, we'll see that in detail. Okay, now the question is, can I apply filters in projection node? Yes. Can I apply filters in aggregation node? Yes. Okay. But point, very very important point. But we cannot perform filtering in aggregation node or projection node, which is a default node. See, I said this is a default node. You cannot apply filtering in the default node, even though the default node is aggregation or filtering, you cannot apply filters. For example, this aggregation, right? Default node. Let me take business partner. Now see, can I apply filter here? No. But in normal aggregation node, I am able to apply filters. I have the option. So in the default node, whether it is aggregation or projection, you cannot apply filtering bus. Okay. For example, if I take another view, if I take ZCC, where default node is projection, let me say I can apply filter on this or not. No option of filter. See, you can apply filtering in projection node or aggregation node, but not on the default nodes. Not on the default node. Okay, good. Okay, next is every time you create this calculation view, and one more point. See, in the default aggregation, I have an option of restricted column also. We'll come to that later. Okay. Okay. Now, what I want is in for every, so this is like a canvas. Okay, whatever we're able to specify, this is a canvas, and any node you select, this right screen will, the detail screen will show the properties of it or the definition of that node. Okay, and every time you define a view, you have semantics also. In the semantics, you get to see different set of properties, which tells you what columns are selected in this view, then some view properties, whether what is the data category, what type of this view, session client. We'll have lots of properties on this. We'll see that. Then we have an option of building hierarchies. Then we have an option of building parameters or variables. We'll see that difference later. But now you can understand this input parameters or variables are used to make your are used generally when you want to make the definition of the view make dynamic. So when you don't want to fix the definition of the view based on some input from the user, you would like to have the definition of the view to be maintained. Then what you can do, you can just define a input parameter or a variable which can be inputted from the user, and based on the input values, we go about doing the definition of the views continuous. Any reason not on default node, or it's just designed like this? I don't know why that is done there. Because actually there is a problem. I'll tell you why it is. You don't have to go to that level, but in case of aggregation, in the default aggregation, when you apply filtering, you might have a problem of whether the filtering should be done first or aggregation should be done first. So I think there is some SQL engine problems. Um so that's the reason. In the backend, they have some limitations on the SQL what has been written. So that's the reason they have limited it out. Okay. So like this, you can basically use this all this kind of different operators and then define your calculation use case. Okay. Hmm. Similar way, I can also create my calculation scripting based. Now new, and say ZCV underscore 006. But this time I would say not graphical. I will go scripting based. Then whether the coding could be case sensitive or not, it differs. So when you go with scripting based calculation, we will just have only one node, no other operators, only script view and semantics. Semantics is again same about displaying about the columns, what has been outputted, and the view properties, hierarchies, and then parameters. And a script view, you'll see a script-based editor, where you can basically go instead of, so you'll have var underscore out. You can start writing your script and SQL script and assign data to this. Var underscore out will be your output table, and you just assign the complete result set. You basically write your select statement in such way that whatever the result you want, and assign that result set to this output table var underscore out. That's it. This is about script-based calculations. Like this, you'll have columns, parameters. We'll see the in detail, but we can also create a calculation with scripting based like this. So we can have a calculation which is defined with two types. One is graphical or scripting. And one more point is after I create a script-based calculation views, after I create a script-based calculation views, they can be converted as graphical also. They can be saved or migrated as graphical. So you can create a calculation with scripting based or graphical based. And once I create a calculation with scripting based with script, I can convert that as a graphical calculation view also, or I can migrate that as graphical calculation. Okay, good. Okay, now can I use calculation view within a calculation view? Boss? Yes. Can we use calculation within calculation? Yes. Once we define a calculation view, I can reuse that into another calculation. That's why I was telling you when I go to, sorry, I was using 5, right? When I was going to 5, so I use some tables here, right? It need not be table. It need not be table always. Any source of I can instead of table I can use another calculation view into this. Say for example, say in the rank node, instead of using table, I can use some calculation view. Say there's another calculation, I can use this calculation. I know it's not active, but let me just act. See, if I make it big, that's a problem. I don't get to see all the options. Authorizations, huh? I will see that later. Now let's not. Okay, boss. Okay, but see, it's not that I can use calculation view or I can use other attribute view or article views into this. Tables, database views, column views, all those can be used into this as a nodes, not only table views. Okay, we'll see later what all can be used. This all can be used like this. Yeah. Now let's take up one scenario and then, but if I'm zooming it, that's the problem. You don't get to see all the screen. Yeah. Simple. I just want to build one calculation view for now. Yesterday I was telling you about all those details about business partner, right? So we have got business partner table, we have address table. If you remember, I just want to create a simple one. Okay, now just I just want to create a calculation which can give me business partner details. Okay, ZCV and say business partner basic. So I want to create this as a normal calculation view. Type standard, graphical is fine, but this is just like a master data. This is just like a master data view where there are no measures, right? So I'll go with what? Dimension, say finish. You might get some one error. Okay, so what you have to do is before you create the modeling, so you want to create your HANA modeling by using tables of which schema was SAP HANA demo, right? So actually what happens, the entire modeling is handled by a user called sysrepo. So you must have access to that schema. So what you do is you have to grant select on schema. Which one is it? SAP underscore HANA underscore demo to user. sys underscore repo. Sys repo is a system user who takes care about managing all the modeling content. Okay, he must have access to your schema with grant. If he wants, he can grant to others. Okay, so you must grant this select access on the schema. Okay, incorrect syntax. Grant option. Initial, you're not authorized. Okay, I am not authorized. It seems so. Only system user can do. So I'm just connecting the system with a different user who has got authorizations who can do this. So from this user, I will run this command. Yeah? Because I'm the HAN user. HAN user does not have authorizations to give that, so I'm just connected to a different user. Oh, ho, 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 ho. Even this fellow does not have. At least selected. Okay. Hmm. Yeah, it is changed. Now no issues. Plus. I've given authorizations. Done. Okay, now let's do this. So what I want is I just want to build a calculation which can give me details of business partner. So first I would like to take table one. So take the projection of table one. I'll just go with drag and drop. So if you scroll down, I have this business partner table. Let me take this one. So from this table, what all columns you want? I just want partner ID, mm, partner role, and the name, and whether it's private limited or what. Just that's it. I don't want anything else from this table. So just project only those. Next, I would like to project another. You can rename this, saying if you want to really understand this, you can say rename. You can say BP projection. You can rename your node like that. Then second projection, I would like to project the columns from the address table. From the address, I want, okay, I need this, okay, fine. Let's see what is the problem. I want address ID, city, and then country, region, nothing else from this table. That's it. Then I would like to rename this as the projection address, some name, this node, and then I would like to join these two nodes. So then I use the what? Join operator. Then get the business partner node, address node, both connected. GraphQL to SQL is not available, only SQL to GraphQL is. Now from this, now I would like to join. So I would like to join it on the address ID, right? But I don't have address ID in the BB projection, so I can't. So what I can do, I can just go back now, choose the address ID which I need to join it. I can just add to output, then immediately you'll start getting it here. Now I can join this. Now in this join node, I'm not using tables, I'm using the sub nodes. Okay. So I can join it here. I can say right click, create join projection, and then I have this here, and I would like to join it on the address. For now, don't worry on the join type. I'm just going with inner join. That should be fine. We'll discuss on the join types later. I'm saying okay. That's done. Now from this table, what all you want to select? Just select this from the legal form. I want city, country, and region. See, you see, all these are selected to the output. All these are selected to output. Yeah, order ID, all this stuff here, columns. Then what are the default join? You join it to the default projection now. In the projection, this is the no columns. Then you can just I want all the columns. So you can use shift button and just select all and add to column. Yeah. And then you can go to semantics. Then you get to see this symbol indicates it's a dimension bus. You get to see all the column names: partner ID, role, company name, city, and this. There is view properties. Don't worry now. That's it. And then I'm going to activate this and you get the messages. It has been activated successfully. Bus. Once it is activated, you can see. That's why if I zoom, this is a problem. So once it is activated, I can basically I can see the data in this view from here, data preview, raw data. You can see the raw data, or you can see analysis on the. I can want to see on the partner role wise. You can see the distinct values. Say partner role wise how many. So there are with partner ID 2 there are 6, and one with partner ID 1 there are 39 count. There are totally 45. This total 40. This is the data. If not, I can apply filter and then see here for runtime. I want to see only Asia Pacific. I can just right click on this Asia Pacific and say quick filter. Then you get to see. You can see this filter applied to the right here. I'll have to close this and execute again so that the filter is removed. Like this, you can basically build your basic calculation views. Okay, a simple one. Now in the join node, we have to go with different types of joins depending on the requirement. Then and they can say auto layout. It will basically adjust. And like this, you can start building your logic or implementing your logic with these different operators like join, union, projection, aggregation, rank, and then implement your logic. And then once it is done, we can expose these calculation views to your reporting views. But you can only expose the calculation views for reporting where the data dimension is what? Where the data category is cube. Here the data category is what? Dimension. So I cannot go with the reporting on this. Only if it is cube, I will be able to do reporting on this. Okay. So this is just a basic entry or a basic understanding how this calculation view can be created. And one very important point, I activate this view, right? What is my calculation view? ZCV underscore BP underscore basic. Every time a calculation view is been activated, it automatically creates one column view. I'll tell you what is that later, but look at this here. In the view properties, you see this column view saying sysbig, and the column view name is Q modeling so and so so and so. So if I go to my sysbig schema, I should be able to see my this column view bus. I can also use this column view also for reporting. Okay. So if I go to my which schema I was saying sysbig, right? You can go to by default it always does that. So whenever you activate a calculation view, it automatically creates a column view in sysbig. Go to sysbig schema, column views. There are many, but I must apply filter. ZCV, give a calculation view, ZCV underscore BP underscore basic. So the definition of this view, see, look at it, this is a column. I can also see the data on this column view also, okay. Or I can see data from here. I can see the model calculation BP01 basic. It's activated, right? See, this symbol indicates active, this indicates inactive. From here also I can see the data on this data preview. In the BO layer, basically in the IDT universe, you can consume like table. This you can consume this column view as a table, normal table, and you can have this calculate. Any of this can be consumed in the BO layer. Okay, whether it is column view. So whenever I create a calculation view, it automatically creates a column view in SysBig schema. Very very important in the interview point of view. They ask this. So every time you activate a calculation view or attribute analytical view, either of these views, they create a corresponding column views in SysBig schema. This is about the basic about creating your calculation view. Okay. What is the purpose of column view? Like column is what which basically holds the complete definition of what we have done. Yeah? Look at this. Whatever you've done, it has basically built all the logic into it. With drag and drop, it builds the logic into it. And this can be exposed as this is like almost like a procedure based calculation, and this can be exposed to BO environment in IDT. Okay. So this is you can understand this column view as a runtime object what is built in HANA for you. This is a design time object, and column view could be a runtime object, which both are available in HANA itself. So this is the basic about calculation. Tomorrow, so before we go, before what I want is I just want to show you one more where I use this BP and then create some sales and then do some small reporting on top of it. So you know the entire cycle. Okay, you create calculation view and then you do reporting. Then the major focus is I would like to discuss on the different types of joins, inner join, all those stuff. So tomorrow I'll focus on creating another calculation view which will give you sales data. Then go on doing some reporting on top of it. Then so once you know the basic understanding of what calculation view and how we're building it, we can get into understanding different types of joins. Then get back to calculation view in detail again later. Okay. Apart from yeah, I'll provide that video materials also. I'll share it because I was not able to provide that there, but I'll share it in the email or something. Okay. How long this videos will be accessible? It will be accessible for 5 years. Okay. Okay. The videos what you're seeing will be accessed for 5 years. Okay. By that time, new version comes. So don't worry. Yeah. Today's recording, everything will be available in the portal. I am uploading these videos every day in the portal. Okay. And one more thing. Boss, what you're doing is, see if you see this course, see this is a course you're seeing, right? In see this should be your link, Pratap reddy.visicqxt.com, and when you basically log in, you will be logging in with your ID what I've given you. Eh? Once you log in, see, in the section 1, I'm giving all the current batch videos. I'm saying present batch video like demo 1, HANA tables. Now, today I'll be adding the next video. Every day I'm adding the current today's video here. Day 4, not next day will be day 5. Like this, I'll be adding all the current batch videos here. But I've given additional videos in this section 2 to section 5. Very important. Please spend some time in going through the scripting and videos about SQL database and the scripting was very important because when we go to by the time we go to calculation with scripting base you must know this. Okay, can you provide the file so that we can include the tables in the newly provided access? If you have taken access from Vasu, I'm using the Vasu system, so I already have those tables implemented. If you want, I can also give you those schemas. Today I'll send across those. Yesterday, other day, we imported those schemas, right? I can send you those files, okay? Ready-made content also. And one more point I wanted to mention is with the same application, VisiQXT, you also have mobile app also. You can also access these videos through mobile app also, boss. So when you basically download this app, WIZIQXT mobile app, and if once you log in, you'll be able to see the same set of videos on your mobile also. Okay, fine. Yeah, fine, boss. Thank you. Now tomorrow we'll continue with another uh, more detailed example, and then see how do we do reporting on it. Basic understanding. So by the time we finish complete cycle, then we get into understanding different types of joints, and then get into detailed complex views. Okay, fine. Thank you.
Hello.